In lesson 9.4, you're going to be going over ellipses. So what they are is basically just an oblong circle, and they follow a similar equation with your circles. What we're going to do is we're going to write equations of ellipses, and then we're also going to graph them. So an ellipse is of all points in a plane such that the sum of the distance from two fixed points is constant, and these 2 points are called your foci. We do have two axes of symmetry. One is your major axis, and that has your foci and your vertices of your ellipse. So your major axis does contain your foci. This is obviously also the longest axis that you have. Okay, your minor axis is going to be your shorter axis, and it's going to be perpendicular to your major axis, and it contains what we call the co-vertices. So this would be your shorter, or your shortest axis. So if you go over to your table, we have standard form, and this is when you have an ellipse that's centered at your origin. So we have an x squared over a squared plus y squared over b squared equals 1. And then we also have y squared over a squared plus x squared over b squared equals 1. Whenever your x squared is over your a squared, that is when you have a horizontal orientation. So that's when your graph is going to be looking sideways. Okay, so when you plot it, it's going to be going left and right like that. If you have a vertical orientation, that's where your graph is going to be going up and down like so. It changes with your foci. Now the length of your major axis and the length of your minor axis, these are still the same regardless if you have a horizontal or a vertical orientation. Sorry, I didn't mean to do that. So they'll be the same here. So your length of your major axis is 2a, length of your minor axis is a 2b. Alright, so if we look at this equation here, we have to write an equation for our ellipse, and notice it is centered at your origin. So we will use the one of the two formulas that were given. Notice how the orientation is going up and down. So we want to use our vertical orientation here, where we're going to have our y squared over a squared and our x squared over your b squared. Set that equal to 1. And so what we have to do is just find out what your a and your b are. Well, your a, that is going to be the distance from your major axis, or from one of your vertices, all the way down to your origin. So the distance from here to here is 5. So if your a is equal to 5, now we got to find out what our b is, and your b is the distance from your center out to where your co-vertices. So this is b. In this case, your b is equal to a 3. So in order to write your equation, all you have to do is say y squared over your a squared, which is 5 squared, or 25, plus x squared over 3 squared, which is 9, and that is equal to a 1. So this is your equation when you are given the picture. These are the nice ones to actually write out. Notice your origin is at your, or the center is at your origin too, so this will be a nice little example to start off with.